on under, make yourselves comfortable. There's another couch over here if anybody wants to sit and make themselves comfortable. All right, folks, so we're officially kicking off the Mobile Stage Conference with our sessions. I hope everybody feels comfortable here. I'm excited about the turnout, and we have a great program, a lot of information, a lot of quality speakers, and trying to educate us on important factors that can help expand our business or give us knowledge to make us better business people, making smarter, safer decisions. And we're going to kick off our program with Clark Reader Engineering. Jeff was one of the first speakers I reached out to, and he was immediately totally down with the program. He told me he would be delighted to be a part of this and speak. We personally work together on different projects. Awesome engineering firm, knows everything about outdoor structures and wind rating, and he's going to be talking about that today. So let's kick off the program. Give him a big round of applause, everybody.
All right, thank you very much. This is weird talking with a microphone. I'm used to just talking to everybody, normal voice and everything, so I'm going to get used to this thing. Mike, thanks for having me. This is awesome. It's good to see all you guys. We worked with some of you guys. I haven't put faces to names yet, but I know hearing some of you guys is like, okay, we've worked with them before, so glad to meet you. So what I'm going to do today is just talk about temporary outdoor structures. It's not going to be dedicated to mobile stages. Mike kind of asked to do a little bit of a broad stroke on this, since I only have 45 minutes. So I do a talk at Total Structures for about a day. So I pulled some different things out of that I'm hoping are applicable to you guys. One thing I will tell you, if you have any questions, feel free. I'd rather you guys ask me questions and get some knowledge that you guys want than me standing up here, because as you guys know, engineers are pretty boring. So if you make me talk for 45 minutes, you will all be asleep and you will need more coffee. So ask questions, engage. I have no problem with that. So real quick, who am I? I graduated from Purdue University with my bachelor's and my master's in civil engineering. That was back in 1998 when I got out of school, and I actually started doing power plants out of school. So I was doing stuff completely unrelated to this industry. And about 2002, my wife got pregnant with our first kid. We moved back to Cincinnati, where I'm from, and I started working for a company that did entertainment. Well, they did mostly residential and commercial buildings, and they started doing entertainment. And somehow I got hooked into it. And in 2009, Daniel Clark and myself started in his office, or his detached garage as our office, and that was the beginning of Clark Reader Engineering. And we specialize in outdoor, anything entertainment, theaters, you name it. We do mobiles, we do big concerts out in stadiums, X Games, that kind of stuff. And that's all we do. We do maybe a couple buildings, but I really don't like doing them, so we just stick in this world. It's a lot more fun. Right now, we actually have 13 engineers on staff. We just hired a mechanical engineer, which is pretty cool for us because we're now getting into automation and moving parts and things like that, which we've never done before. So yeah, it's pretty exciting. In 8 years, we're like 16 people now in the office, so it's pretty crazy. Let's see, go back. As you can see, we're licensed in every state in the U.S. We're also licensed in a bunch of places in Canada, Guam, Puerto Rico, and we're looking into Europe to see if we're doing a little bit more there. So we're going to try to, I guess take over the world. I don't know. We'll see. And then finally, you see at the bottom there, some of you guys that have worked with me, I'm a little bit crazy at times. I have 6 kids. So my oldest is 14, my youngest is 9. We have quadruplets that are 10. So besides being in this industry, I also have that at home. So trips like this are really nice.
You're not
really nice. So we're going to dig in here. Like I said, this is going to be a pretty broad stroke on everything, but if you have questions or if you want to engage me on something later, more than willing to sit at the bar, do some napkin CAD, and talk over a beer too. All right, Tish, you ready? All right. So today I was going to talk about codes and standards because I think that's kind of important for you guys to understand where engineers come from. Loads on structures, you guys probably know some of that, but we'll dig a little deeper as much as time permits. Go over operations plans because I know every one of you guys has to have something out there. If you're putting a stage up, you're going to have some kind of plan, like what's going to happen when we get wind or heavy rain or something like that. Ballast and guy wires, talk a little bit about that. I know some of the mobiles you guys don't engage that as much, but it's probably not a bad thing to get an engineer's perspective on the ballast. And then I was going to give you just some pictures of stupid things people do, just because it's fun, and I like doing it. So, and then we'll have time for questions, hopefully. If not, you know, I'll be around all day, so you can pick my brain. All right, difference between a code and a standard. This is kind of important because there's two of these things out there, and I've got, you know, a pretty good definition. A code is a standard that has been enacted into law by a local, regional, or national authority having jurisdiction so that the engineer or contractor is legally obligated to comply with the code. So that's like our IBC, ASE 7. This is where we get all of our, you know, design loads, and they say, hey, you have to meet this. For wind, you have to meet this. For snow, it's got to be this. And so we are legally obligated. It's actually a legal document that I have to follow. So when people say to me like, well, can you not do that? I'm like, well, I can, but I'm not really legal in doing so. So it's kind of a good distinction for people to understand that. When an engineer tells you that we have to follow the code, it's actually a legal requirement. So if I'm standing in front of a judge and jury and something happened, and I didn't follow that for whatever reason, we could be in big trouble. A standard consists of technical definitions, procedures, and/or guidelines that specify minimum requirements for instructions for manufacturers, installers, and users of equipment. So you guys all familiar with like the ANSI documents, E1.21, E1.2. Is anybody not familiar with that stuff? Don't feel bad if you don't. Raise your hand. So basically, what the ESTA, which is the standards group, they're based in the industry. It's made by peers and fellow, you know, industrialists, I guess you want to call it. They write these standards, send them to ANSI, and they're basically a best code of practice. So E1.21 is for temporary outdoor structures, which is pretty much everybody in here should get a copy of that, and it's actually free. It's online, so if you go to ESTA's website, you can get a copy, but it goes through, you know, what the manufacturer is required to do, what the end user is required to do, what the engineer is required to do, so it covers pretty much everything you need. And if you have that on site, you know, it's not legally binding.
Can you spell that ESTA or ASTA?
ESTA is ESTA,
Okay.
and then it's the, I'll have the code up here in a minute, or the standard. But you're not legally bound, it's more of a best practices, but what we're finding is if you have like E1.21 and you're following that, a lot of the building officials will take that. Because that allows for the wind reductions that we take, it's got the high wind plan. So if you show that to a building official, a lot of times they'll accept it. If you guys, anybody do work at Reedy Creek, they won't let you take it. You know, they'll say nobody can enact the high wind plan, that kind of stuff, but we know that you can. So right now the current codes that are most prevalent in the U.S., 2015 International Building Code. It's funny, it's called the International Building Code, but it's only used in the U.S. So, you know, makes sense, right? American Society of Civil Engineers, that is referenced by the IBC, and that is where we get all our design loads from. So that has everything you want to know about design loads. It's like a 1,000-page document on how to load things. So for me, it's kind of cool. You guys, maybe not as cool. There's like 5 chapters on seismic. Aluminum design manual. We do a ton of aluminum design. The current code is 2015. It's not adopted yet everywhere, so we're using a lot of the 2010 still. And there are differences from, you know, the 2010 to the 2015 code. So it gets a little tricky with aluminum. Like the truss manufacturers hate it because, you know, from 2000 to 2015, the codes change every 5 years, and it's not like the steel code. And the steel code doesn't change a lot because they've got 80 years of history behind it. The aluminum code's got about 30 years. So when it changes dramatically and it screws everybody up. So we have to navigate that thing, but it's, you know, it's a volume about that thick about aluminum. Again, it's real exciting. If anybody needs to sleep tonight, let me know. Give it to you. And then the American Institute of Steel Construction, that's the other one we use quite a bit. All right, current standards. Here's the ANSI standards I was just talking about. So they've got one, the first one that's a ASE document 37-14. It actually talks about design loads on temporary structures. It's really for things under construction, but we've also adopted it for what we do because let's face it, a lot of what you guys do, everything's up for what, a week, under 6 weeks. When we get into longer than that, then we start looking at it more as a permanent installation. But the bulk of what we do is under 6 weeks. So it'll fall under all of these. You've got ANSI E1.21, and this is the temporary structures used for technical production of outdoor entertainment events. If you guys don't have a copy, you should get one. That's a very good document. You can show it to code officials, like I said, and they'll actually look at that and give it some relevance. So E1.2 is for design, manufacture, use of aluminum trusses and towers, and then the ESA has got their, I guess, equivalent to the Purple Book, if anybody's seen that. Is anybody not familiar with that? The Event Safety Alliance? So they've got their own book it's kind of like the European Purple Book, and it's got, everything production related. So crowd egress structures, stuff I don't care about that's in there, but you guys probably will because a lot of you guys do food production. So you might want to take a look and get a copy of that. It's a pretty good document. The interesting thing about the codes, the IBC updates every 3 years. The IBC references all the other codes. The other codes get updated every 5 years. And the cities and the different municipalities do not update at the same schedule as any of this. So like New York has a totally different code than Chicago. Chicago doesn't even fall under the IBC. They had their own code because of a fire, 150 years ago or whatever it was. So their code is totally different. Cincinnati falls under a different code than Omaha, Nebraska. So for us, it's kind of a pain in the butt. But the good thing that we have going for us is everything's temporary. So we kind of default to whatever the current code is because it just makes life easier, and we're always going to be designing to a different standard anyway. So we try to pick the latest and greatest and run with that. Any questions on codes? I know that was a pretty quick hitter.
You designed a structure for a company to make finance and services. When that code update, you have to use all the engineering?
Did everybody hear his question? So he asked if, we design a structure and then it gets used over and over again at different places, and then the code changes. Do they need to update the engineering? It kind of depends on the authority having jurisdiction. Some of them will say it's fine as is. Some of them will force you to go get re-engineering and a new stamp on it. It just kind of depends. And if you call us and we know that the code has changed significantly, then we'll probably tell you, yeah, you should have to revisit it. But the codes, by and large, with wind and all that, really what changes anymore is terminology and maybe small things. So you're not getting major changes in the code. But yeah, again, it's going to come back to whoever you're, Epcot, they want it re-stamped every time you use it, even if it's identical to the week before. That's just the way it is. You have a question? We just hired a mechanical guy, so we are starting to dig into it more. We're going to see how it goes. He seems like he knows what's going on. So, but it is a new. We actually have two guys. One guy's a subcontractor for us. So yeah, I guess we can. He's a pretty seasoned guy.
This might be an off-the-wall question, but when you take on a client, do you have practices where it would be like a recurring retainer, or is it project charge?
A lot. No kidding. It depends on the job. It depends on the job. Like a lot of times people will send us something and say, hey, what do you think this is going to cost to engineer? Other times they'll say, just bill us hourly. So it's really up to whoever we're working with, how they want to do it. So, but a lot is the key word. All right, any other questions on that stuff?
We were talking last night, is there any thought towards putting some sort of national standard together so that, I know that's difficult with so many different levels of government that you're jumping through your hat every time somebody wants a particular stamp or a particular set of guidelines that you go by.
I guess your question's kind of
somebody like you might take that ball and run with it and try to standardize it to some degree so that it's not all over the place.
The tough part we're going to have, like I said, we're licensed in 50 states, so no state's going to give up, their stamp to go to like a global stamp because it's all, it costs us a lot to keep our licenses up. However, the codes, the E1.21, they're actually trying to get as part of the IBC, so it'll be recognized as an actual code as opposed to a reference. And I think ESTA is working on that with the IBC and some other folks, so we'll see where that goes. That would be really nice because right now we run into a lot of trouble. Not a lot, but some places, will say, we're not going to accept that. So you have to design your structure that's going to be up for 1 day, 1 hour of that day, to 110 mile an hour wind or something like that. And that's painful, especially because we have weather monitoring. You guys can, there's a lot of things we can do to mitigate the risk. But if you have to design it to that, then you really can't do the show. We run into that along the coastal areas. Atlantic City gets like that. But it would be nice. Anything else? Good questions. All right, we're going to move on to loads on structures. So you guys, this is probably pretty basic, but I thought I'd hit it real quick. You got gravity loads, so that's the self-weight of your structure. That's the rigging load you're going to put on it. That's the environmental loads. A lot of you guys don't deal with snow on your structures. We did a bunch of stuff up in Minneapolis this year for the Super Bowl, so we did actually have to think about snow a little bit, or have a plan to get rid of the snow. You guys probably deal with it up in Canada. And then construction loads, so sometimes we have to take that into account. How are they going to be on the stage decks? Are they going to be putting forklifts and things like that on it? So those all kind of fall under gravity loads. Then we've got the lateral loads on your structure, which is probably the one that gets everybody a little bit less sleep at night. And you've got wind loads, which is probably our biggest issue as a group as a whole. I'm always checking weather. We might have in the summer, 12 big events going on, and I'm looking, we're making phone calls trying to figure out what's going on, because those are the things that make you not sleep at night. Making sure guys have plans, make sure everybody's on the same page. Seismic loads, we have to consider it, but if you really look at what we do, seismic loads aren't going to play a big role, because I do a lot of outdoor aluminum structures. There's not a lot of weight to those. In the seismic, you got to get some mass to move these things. All right, the trailer stages, they've got some mass at the bottom, but they're still light. You look at these; they're aluminum. They're lightweight in and of for the most part. So a lot of people ask me, "Are you guys going to look at seismic?" No, not a whole lot. It just doesn't affect us that much. And some people get freaked out by that, but if you think about it, wind is going to be a much bigger force on our structure, especially when you got sail areas and video walls up and things like that. And then the last one is any forced moving loads, like if you got video walls that are moving up and down the stage or something like that, or anything that's going to make your structure move. So it's all pretty basic stuff. So wind loads I did want to hit. The design wind speed varies somewhat depending on the location of where you're at. So in the typical Midwest U.S., we're going to design for, and if you look, I got 115 mile an hour ultimate wind, which is a 90 mile an hour service wind. The code added this ultimate wind speed in the latest rendition to completely confuse everybody in the real world. Okay, 115 mile an hour ultimate speed is like that 90 mile an hour wind with a factor of safety on it. So they say we're designing for 115 mile an hour ultimate wind, when in reality it's just a 90 mile an hour wind. You guys deal with an anemometer that's real time. You deal with real time winds, right? And nobody's like, oh, let's add a factor onto that and then call it wind speed. It's a 40 mile an hour wind, that's what you're dealing with. So that's what we try to make sure we're dealing with is real winds. So we break that 115 down to the 90 and then go from there. The one thing that we do per ASC 3714 and E1.21, we can reduce that wind speed by 25% if it's up for less than 6 weeks. Is everybody aware of that provision? Why? Probability. It's basically a probabilistic look and saying, okay, if you're going to have it up for less than 6 weeks, they're saying you're not going to get a 50-year win. Okay, we're going to give you maxed out on like a 2-year mean recurrence of a high wind event. So you get to reduce it down to 67.5 miles an hour, which is really nice because wind is an exponential pressure. So a 67 mile an hour wind versus a 40 mile an hour wind is actually like a factor of, I think you get a 60% difference in the pressure, which is quite a bit. You know, if you go from a 90 mile an hour wind down to a 40 mile an hour wind, it's like 3 times. So it's a big difference. So what we'll do is we'll design it for 67.5 with like a full skin on the roof. All the sidewalls, all production's taken down. And then we'll use, say, 40 or 45, depending on what we need for that particular show, with full production on it. Does that make sense to everybody? Seen that before? No surprises? Okay, good. Let's see. Yeah, if you look, it said it equates to a 43.75% reduction in wind pressure on the structure. I'm not an engineer, but 43.75 is pretty particular number there. Like I said, seismic loads. Is there any other questions on wind before we move on to seismic?
Have there been any standards or codes enacted that require a stage that has wind curtains that have to have like an emergency drop system?
If you read ANSI, it's got some verbiage in there that says, okay, if you're going to design it for, at a minimum, you got to hit 40 miles an hour with full production on it. After that, you have to be able to take production off in like 5 minutes or less is what they say. So that should answer the question. A lot of you got to be able to either take it off really quick, so maybe it's on a shiv and pulley system that you can drop. Some of the guys that, the bigger stages we do in the stadiums and stuff like that, they'll actually start pulling skins at 15 if they know they're going to get 30 because you can't get the skins off. They're all teetered in. But the idea is that you can get everything off in 5 minutes or less, or lower than you need to. So that is in the standards.
Does that apply also to the backdrops?
Absolutely. It applies to backdrops, sidewalls, video walls, speakers, basically anything that's going to grab a lot of wind. The roof skin itself, on these, there's no roof skin, so you have to design it as an empty structure like that. But on a stage where you're pulling skins and putting skins on, unless you're going to lower the roof, then you have to design it with the skin on. It does say 5 minutes in there.
So our video walls are going to possible.
It's
Awesome.
Yeah, I mean, you basically got to drop it and secure it. That's about the best you can do with the video wall. But yeah, it does say 5 minutes, which can be, it's a little bit unrealistic because if you're waiting until you got 5 minutes left to go before the wind hits, you've kind of screwed yourself anyway. You should be looking at the weather way ahead of time going, okay, today I'm going to get 50 mile an hour winds and it's going to hit sometime between 4 and 5 p.m. So we're going to happen, yeah. I mean, we've had that happen at Lollapalooza a couple of years ago, 4 or 5 years ago. We evacuated from the site, and they knew at noon, 3 o'clock, things were going to get taken down. Yeah, very proactive. So you got to have the plan. Anything else? All right, earthquakes. Like I said, varies on the location. Sometimes they do make us look at it, but a lot of times once we run the numbers, it doesn't control anyway. So, and the other part of it is the code does not specifically say how you should detail for seismic. So in building design, you get into the code, it says, oh, you have to detail these connections for seismic just like this. And they give you a very specific way you got to engineer it and design it. For aluminum and for stuff we do, there's nobody that says SCAF's going to be designed for seismic because of this connection. That's just not how it works. So like the mobile stages, they get looked at for it. But again, like I said, wind's going to typically control the design of that. All right, operations plan. Does everybody have one of these that they carry around with them? And if you don't, why don't you? These are kind of this is your out card, I guess, I'd say. We send them out with pretty much every temporary structure we do. and it's up to you guys to use them. A lot of guys have their own little booklet that they keep in there that has it in there, so they can show the client. And it's really good. You got to get buy-off from the promoter or the venue, whoever, wherever you're doing this at. Make sure everybody's on board. You know, our typical plan. You know, we have a top part that talks about the implementation of the plan. You know, who's responsible, who's in charge, all that good stuff. You guys have to have that established before you start the show, before you start the installation. You know, who's going to make the calls on this? Daily operations plan. So we have some stuff that says, you know, if you've got ballast out there, you got to check it. Check your guy wires every day. Make sure that you're keeping a log of this stuff. That way, if something happens, you can say, listen, we check this every day. Everything is good to go. And this event that happened was a freak event, but we did everything we could to make sure that we were in the good graces here. And then the other part of this is the high wind action plan. So this is where we get into what you guys actually have to do. So we typically set ours at 20 miles an hour. So at 20 miles an hour, you're getting the crew activated and getting them ready so that they're on alert and on standby. And then after that, you know, then we go into at 30 miles an hour. We're getting people out of the spots. Maybe it's even sooner than that. Depends on the show and what we're doing. And things start happening at 30, so they might be lowering some PA, or they might be lowering scrap.
And all these numbers for wind speed you're giving out, are these 3-second guesses?
It's everything we have is a 3-second gust. That's what ASC is based on. That's the best we can, you know. If you sit there and say, well, it's got to be sustained or it's going to be a gust, it's kind of hard because you're going to be sitting there like this the whole time, like, oh, okay, that's a gust, but we don't need to do anything right now. You know, hopefully you're doing all this action before any of this wind comes. If you read our notes, it says when wind speeds are expected to exceed. So we're not waiting for your anemometer to hit it, because you wait for the anemometer to hit 40 and you're screwed, because now people are still there, you haven't gotten them out. You got equipment that's going to be flying. And at 40 miles an hour, all these chairs are blowing away. So you've got to be proactive with it. And that's why we always put the expectation of wind. We have some other notes, you know, like if the system's not in use. We put a little blurb in here about general notes. Is there any other questions on ops plans? That's kind of a big ticket item, but you guys all seem to have a little bit of a handle on that. Yeah, absolutely. Well, Mike, they can get copies of all these. You can send them out to everybody. Okay.
I can email.
Is that the plan right there?
The two before were the actual operations plan.
Okay.
Yeah, this we'll send with it. This is kind of our general notes page. So we send this. This is more to pacify the building official. It goes through like what design loads we use, what the codes what we used are. It basically sets the baseline of how we did our design. So you guys should probably read through those if you get something from us or any other engineer that has them, so that you know what it was designed for. Okay, that sets the baseline. So you might look at it and say, well, he only designed it for 20 miles an hour. What the heck? Well, I wanted 80 out of this thing. So make sure you're reading through these things. But we go through, you know, the event date and location, code reference, design loads and assumptions, ballast, foundations, ground anchors. We get into all that kind of stuff in the notes. I can't dig into all that today just because of time. But if you have any questions on specific stuff in it, let me know. We could talk over a beer.
Are you sending that action plan out as an email attachment by any chance?
I can send it out in a packet to everybody who I
That would be a great
email
attachment.
I can send that to you.
And I'll come up. I'll just give you a
Yeah, I'll just,
generic one.
whatever presentations we have for today, I'll send out in a packet again.
And that would be a great attachment to a contract that you send to a promoter. Because it's always that battle of who's shifting liability to who, and they're going to try to shift it to us. Well,
A lot of guys we work with will actually have a line item for the promoter or whoever they're working for to sign it, because that'll dictate the terms. Like, you know, if you're it's your stage, and you guys should make the call if you want it up or not, and whether, not the promoter, not anybody else. It's your toy, you know, and if you don't like what's going on with it, you should pack it up and take it home.
you should let them know that when it gets to that point,
Right.
that you're the guy, and you're going to make the call because
Right.
they think they're the guy. So,
Yeah, so you should get, honestly, you should get them to sign it. I've got some other ones. I've got a whole list of them in my office. Like, I've just got hard copies of old ones, so if anybody wants a copy of one, some of them dictate that. They say, you know, I'm going to be in charge of the high wind plan, and they make the guy sign it. That way he knows. You can't get to the end and say, well, no, we're going to have to show because I say so. That's not how it works. That's a good point. Anything else? Ooh, I got about 10 minutes, so we're going to have the motor here. Yes?
Do you work in carburized? Would you?
We have, I wouldn't say it's our sweet spot.
Would you?
Maybe. What is it?
There's a Georgia that shows all their permitting process, and they didn't tell anybody until 2 weeks ago.
Yeah, I'll talk after. Yeah, we can talk after for sure. Alright. Alright, we're going to hit ballast real quick because I think it's kind of important. This is kind of what it says in E1.21 about ballast. The amount of ballast required at the termination of each guy wire rope is dependent on a number of factors. These include the force to be resisted, the nature of the bearing surface, the type of ballast used, the angle of the guy wire to the ground, the coefficient of friction between the ballast and the ground, and the factor of safety to be adopted. So everybody thinks ballast is just weight, which it is, but there's like a whole list of things that go into ballast engineering. Okay? So we might ask you a ton of questions about if you're going to have ballast out on your site, like, hey, what are you putting this on? What are you using? How are you connecting it? That kind of stuff. This is just a real simple, I don't know if you can see it, but basically, you get guy wire tension in your ballast, you're going to have an uplift force, you're going to have a sliding force. So the ballast has to be designed for those two components. We'll put a factor of safety of 1.5 on that. So if you look at the bottom equation, which I can't hardly see, but it says ballast required is equal to the sliding times the factor of safety, and then it's divided by a coefficient of friction. So that's usually 0.4, somewhere in that realm with the stuff we're dealing with. And on top of that, you add 1.5 times the uplift. So you end up with a pretty good sized block of ballast after you get done with all that. Because the sliding really controls. The sliding's like, I think if you add the factor of safety and coefficient of friction, it's about 2.3 times whatever the force is, and the uplift is 1.5 times. So you get a pretty good healthy jump on it. Types of ballast, pretty exciting right there, right? You guys have seen all that stuff. T-blocks, concrete, water tanks. There's all kinds of other stuff out there. I don't care if you can engage 1,000 pounds of feathers and we can make it work, I'll do it.
How many states have outlawed flowable media?
I'm trying to think. There's a couple places that won't let you do it.
I know California won't.
They won't. The one thing about California is they'll say you can't resist any seismic loads with ballast because the ballast can move up and down and slide too, but we have no other way to, unless you're going to go put earth anchors in stadiums and stuff. The big thing with water is you got to make sure you're checking it every day. Because if your tanks are getting, they have a leak and you don't catch it. I had a job once where I'll show it to you guys later if you want. We had a roof that got a 90-mile-an-hour wind on it and stayed up. One of the ballast block tanks actually lost water beforehand, which was, it's kind of cool that the whole thing stayed up too. But it's a pretty neat video. I can show you guys later. Yeah, the water's getting kind of, some places like it, some places don't. But by and large, we still use it quite a bit. I like concrete just because it's. I show this one because sometimes people don't think about how they're attaching the ballast. So if you look at this picture here, on the one on the left, you can see they attach to the end of the ballast block. Okay? I got a call from that guy. They got a 30-mile-an-hour wind while they were putting the video wall up, which I was trying to figure that out still. But it basically grabbed that ballast block and yanked it to the side. Because if you look at it, you're only engaging half the weight you pick that up. So I had to change it to the one on the right side there, where we get the ballast in line, then you're engaging the whole weight of it. And he was on gravel too, so we had him at some tent stakes in there. So, like I said, tying the ballast matters, the base matters. So you got to think about all these things when you're doing ballast. It's not, because if you take one of those totes, they've got the half-inch aluminum bar. You'll bend that if you just grab that. So you got to think about when you're doing ballast. I know you guys with the mobile stages don't do it as much, but Yeah, I thought it'd be good to touch on at least today.
That's what I was fixing to ask you, is that related to structures because I was kind of left with the impression, having told that if you do a balance, you're not mobile stage. You really don't know that who you're putting on it.
Oh yeah, if you start cranking on it, like we've had guys that can't get the roof straight because they keep cranking on it, they get it real tight this way, then they pull it back the other way.
I've been told by the state line not to use balance because I don't know what kind of creating.
Right, unless you're gonna dyno it, which nobody carries a dyno to tension their guy wires. I haven't seen it yet. Yeah. And, well, the mobiles, a lot of them have enough self-weight at the base anyway that you're not so worried about adding ballast to it unless you have a weird situation or somebody wants a higher wind rating than what you've got.
Probably be better on the base.
Oh yeah, absolutely. Any other questions on this? Here's another one I had. If you look at the one on the left, the guy ran the guy wire through under all the loops, so it only attached to the back ballast. Well, what happens if that thing gets tension is it tries to pick everything up, so you get this real nasty catenary force in the cable.
Zip line.
Yeah. Luckily, the guy, when I got on site, said, I don't think I like what I did here. And, you know, he kind of said, how do we change this?
You attach the strap. The angle of the strap, is it like a certain roll you just stay at? Maybe high, down, or?
45 is nice. And it kind of depends on what you're trying to get out of it. Sometimes you need more uplift resistance and sliding. And sometimes you need more lateral resistance and uplift. So all of it kind of plays into it. But if you're just going off the cuff, 45 degrees is good. That keeps everything in a nice even 1-to-1. All right. This one I actually like. This was a picture I took that was a good thing. So I just, they engaged all the ballast with different bridles and different pieces. So that one I felt pretty good about. This was at the Super Bowl about 4 years ago. So I actually told them they were going to get a kudos on theirs. And then these are just some details we have. You guys can look at these in more depth. These are how we, in the engineering world, want to tie to the ballast. So there's some different, I've got concrete details. I've got water tanks and how we want to tie to these. All right. Any other questions on ballast? I'm going to get into stupid things people do. Yeah, everybody does.
We don't talk about
Yeah. If this is your stuff, I apologize. So we'll see where this goes. Usually, every now and again, somebody will be like, "Hey," I'm like, "Sorry about that. That was dumb." So this was a stage we did. I got a call from a guy. We were doing the stage back here. That was ours, and I thought he sent a picture of. He's like, "This is what we did." And I was like, "What?" And he's like, "No, I'm just kidding." So he sent me this picture, and so this stage is pretty good size. It's like a 40 by 40. These blocks are about 2,000 pounds, so they had 4 of them. And then you can see how they connected it to the ballast on the right side. It's like 2 side turn shackles to then it's got the hook on it that's going through the hook, so you can just rip the weld of that hook out. So it was about 3 or 4 years ago. Pretty wonderful. This one I got a call at about 5 in the morning from a guy in California, which means it was like 2 his time. And he's like, I can't find the guy that's babysitting this stage. And I don't know how well you can see it, but basically the whole roof's getting filled up like a swimming pool. So the guy that was on the big stage was like, I'm not sure where this guy is, but I ain't touching that one. So apparently they had to go out. They finally found the guy. I made some phone calls, and he was sitting in a trailer doing nothing while this was going on his roof. So he ended up buying new skins, obviously. The one on the left, I don't know. Somebody sent that to me, and I just thought it was disturbing. So I sent it. And then the other one was actually at down in Brazil. I got a call from ESPN, and I know it's hard to see, but they built like a roof and put it on a scaff. Well, the scaff just had this little kicker sitting on one cord of a truss, and they wanted to hang about 30,000 pounds from the roof. So the guy from ESPN was like, what do you think? And I was like, I wouldn't do it. Apparently the engineer in Brazil signed off on it, but they removed a lot of the production. But we get into a lot of weird stuff like that, scaffold and you know, grids like that. This one I just thought was cool because if the truck drives away, that's taking the stage with it. And I'm not sure exactly how the, you know, my hope is that I got this picture because somebody was going to get wind, so they added some extra straps and stuff because it looks like there's guy wires in the background. But even the truck itself, I don't think it's meant for that kind of load. Those frames are not. So I just hope the guy kept it apart and kept the keys so that nobody could take off with it. You can't really see this, but that thing's held up by zip ties connection. So that's actually a truss-to-truss connection with zip ties. Somebody sent that to me. So
I want to know the manufacturer of those zip ties.
it's amazing. I mean, this stuff happens all the time. It's kind of a little bit creepy, to be honest with you. We try to make sure the guys that we're working with kind of have a clue. So. That's it. That's all I got. Any questions? Anything you guys want to discuss? I don't think we're right on time. And I'll be here all day, so I mean, seriously, we can sit down and chat anytime. I'm pretty agreeable. Nothing. It was that awesome.